Hello everyone, my name is Fatimah Curumtally from Université Mascareignes in Mauritius. I am here to present to you my paper on real-time flood monitoring and prevention using IoT sensors in developing countries. I have been working in close collaboration with my lecturer Rajiv Kudiram on the project. So let's go through the agenda. So I'll start with an introduction, research objectives, architecture diagram, methodology, IoT sensors used, a demo of the project, business benefits, and then the conclusion. Floods are among the most common damaging natural disasters that cause significant harm to life, spread of diseases, property, and economy. Due to climate change, scientists hardly understand where the next flood calamity would be, and as such cannot do any predictions to warn people. Damage to houses and buildings are prominent and cost a lot to repair. The need to have real-time monitored data such as flow, precipitation level, or water level is essential in order to make informed decisions on the actions to be taken to prevent flooding. However, there is no efficient flood monitoring and alert notification on the market in Mauritius. Our paper presents flood alert, an intelligent system that detects the water level in specific regions so that residents could prepare themselves for caution to minimize the damage caused by flood. The main objective of the proposed system is to serve as information channel for flooding between the involved authorities and the public in response to the need for information on water condition and flooding in affected areas. The proposed system detects the water level and the rate of water flow using Internet of Things IoT sensors technology. An alert is sent to the subscribed users in case of flood in his or her area. The experiment has been carried out successfully on a miniature model village and lake to simulate a real-life flood situation and how life can be saved. Flood alert is composed of 3 key components: a miniature model with interconnected IoT sensors, the mobile app, the application server, and the database. The website is developed using Django framework and MVC framework based on Python and MySQL as the relational database. The mobile app is built using Ionic framework from which an Android app is deployed. Our experiment was carried out on a miniature model scale model with a lake, roads, and landscaping divided into 4 regions labeled North, South, Center, and West. The water level sensors are connected to the Raspberry Pi board. A water pump is used to slowly pump water from a bucket, and a water flow sensor is connected to it so that it can measure the water flow rate. A stepper motor is placed near the road and acts as a road barrier. As water flows into the miniature model, the values recorded from the water flow sensor are sent out to the Raspberry Pi, which in turn transfers the data to the remote database via REST API. Once water reaches the water level sensors at different levels, data is transferred to the remote database via the same process. So a range of values is associated with a status. For example, if 16 millimeters to 20 millimeters of rainfall was recorded in the region North, the status is alert, and it means that the region is flooded. So 4 statuses have been defined. We have the alert, standby, beware, and safe. If the status is alert, the road barrier is closed and a push notification is sent to the user. So now we are going to see a demo of the project. So thank you for your attention. So I'll now go through the major outcomes and results. So as you can see in the video, all information about the flood could be viewed using an internet-enabled device. Authorized users can view water condition on the real-time monitoring dashboard directly from the web via the web browser or by downloading the mobile app. So once the water starts flowing from the water pump and water reaches the water sensors, the graphs on the real-time monitoring dashboard shows the latest readings from both the water level sensors and the water flow sensor. So if flood is detected in a certain region, a push notification is sent to the registered user and instructions are sent to the stepper motor to close the road barrier. So we have conducted further analysis with the rainfall data collected from the sensors. So the rainfall data with its associated date and time were extracted, and the vector autoregression technique, which is a time series forecasting technique, has been used to forecast the rainfall level for a particular region using machine learning. So to compare the data with real-life data, historical rainfall data has been extracted from the Meteo Mauritius Sylvius Convivium website from the year 2012 to 2021, and the data is posed to the machine learning algorithm to compare the results. So as you can see here, the first graph shows the historical data extracted from the website, and on the second graphs, as you can see on the dotted line, these are the forecasted data from the algorithm. So the business benefits of using flood alert is to gain insights about the water condition affecting a country during heavy rainfall by providing a platform for communication between authorities and the public to provide information about flood. We are providing a website as well as a mobile app. So secondly, placing IoT sensors in different regions across the country to detect the level of water, and real-time data can be transferred automatically to the server. Consequently, the data can be viewed in real time on the dashboard. IoT devices minimizes the requirement for skilled staffs to maintain and update the hardware. The analytics functionality on the platform enables the users to retrieve data at any point in time. The time taken for a flood to occur in a region can be determined. Using our machine learning algorithm, we are then able to use historical rainfall data to carry out flood forecasting. Registered users automatically receive push notification in case the flood condition is critical. The process is automatic, therefore little maintenance needed. Compared to existing papers, this experiment demonstrates how we can use IoT not only for remote sensing but also to take action by closing road barriers automatically without human intervention in case of flood. IoT plays an important role in informing people during natural disasters. In this paper, we have presented our experiment in implementing IoT solutions for flood detection and prevention. The real-life flood condition has been simulated successfully using a miniature model on which water level sensors are placed in different regions. The data from the water level sensors are then transferred to the remote database and can be viewed in real time on the dashboard from the website and mobile app. In case of flood, the road barrier on the miniature model was closed and a push notification has been sent to the registered user. Using our machine learning algorithm, we were then able to forecast flood using historical rainfall data from our website and also from meteorological website of Mauritius. We cannot avoid disasters such as flood from happening. Our system provides a pervasive early warning system and serves as a platform to communicate information about flooding conditions to the residents in affected areas so that they can evacuate, inform drivers to take alternative routes, and inform parents to fetch their children at school. Our next step is to deploy the project in real life by placing water level sensors connected to a wireless network in flood-prone areas, rivers and lakes. So the challenge that we might face is to ensure that the sensors are connected to the network and receiving data at all times. So thank you for your attention. Any questions?